Okay, so I've done a little bit of an extra video for you, just to back on to the lecture video that you've already probably seen, really just to go through a worked example of as to how to follow a Turing machine and to trace through the value of the Turing machine as it's moving around the finite state diagram, as you could well be asked a question in an exam on how to do it. So what you'd usually be faced with would probably be the first line or first row of a Turing machine, and you'd be provided with the finite state machine, which represents the Turing machine. And then what you'd do is you'd basically go through it line by line, and then you would trace the values row by row as you move through it. So to sort of try and demonstrate how this works now with a very short example. So as it currently stands, this is the paper tape of the data. We have our start position, which is SO, which reflects in our diagram. And then basically what we do is we read the data and then make our adjustments according to what happens in our Turing machine. So in this particular case, we are at SO and the read write head is here. We read a 1. So if we're at SO and we read a 1, we write a 1 back, so that stays the same, and we move right. So we move right, and because of that we remain at SO. So we label that up, and the data hasn't changed because we read a 1 and we wrote a 1 in the same position. So we don't need to alter any of these. So we're currently at SO, or we are at SO anyway. We read the 1 where the head is, we write a 1 back, and we move right. So we move to there, staying at SO, and the data doesn't alter. Like that. So we stay at SO, we read a 0, we write a 0 back, so that remains unchanged, and we move right. So we move right, staying at SO because it tells us to in the diagram, and the data remains unchanged again. Now this is where the change takes place. Currently the read write head is here, and we read a space, which means that we're on this transition. So we read a space, we write a space back, so that doesn't alter, and we move right. So we move right, but because we've moved right, we've transitioned to S1. But none of the data alters in this particular case. Now we're at S1, and we read a space, we write a space, and move left. So we move left, and we've transitioned from S1 to S2. And obviously because we've written the same data back, none of the data remains the same. Now it could well be that in this particular sort of question they would ask you something like, given the data in this particular stream, would this data stream allow you to go from a start state to an end state? And clearly we've proven that, because by going through the transition of this Turing machine, we've reached the final state of S2, which is our closing state, and we've proven that by tracing the values through based on the values that are stored in the finite state machine.